Welcome back to another M&S tutoring video, and in this video we're going to be starting our third unit in grade 10 math, trigonometry. So today we're going to be learning one of the basis lessons of trigonometry, solving and identifying similar triangles. So when you're actually identifying similar triangles, there's three different relations you have to look for, and if either one of these relationships exist between two or more triangles, then you can tell that these triangles are similar. So let's get started with the first relationship between identifying similar triangles. So let's look at it, and the first relationship number one, is the angle-angle relation, right? What this means is if two triangles share two pairs of equal angles, we know that both the triangles are similar. So say for example over here I have triangle A, B, C, and over here I have triangle D, E, and F, right? And I know that both of these triangles are right angle triangles, and both of them have the same angle B, and this triangle over here has the same angle E. I know that both of these triangles are similar because they share two angles. If we know that two angles in a triangle are the same, the other angle, which in this case is A and F, will also be similar, because since all angles in a triangle add up to 180 degrees, if we know two angles and if they're the same, we also know that the third angle will be the same in both triangles. When you're making a similarity statement between these two triangles, you have to write it corresponding to the congruent or similar angles. So in this case, the similarity statement would be triangle A, B, C is similar, and you have to write it in the same order as first of all which corresponds with A, and then the angle that corresponds with B, and then the angle that corresponds with C. So right now the angle that corresponds with A is of course F, so triangle F. The angle that corresponds with angle B in the first triangle is angle E, and the angle that corresponds with the letter C in the first triangle is in the second triangle, angle D. So the similarity statement is triangle ABC is similar to triangle FED. So now let's move on to the second relation, which is the side-side-side relationship. So what this means is it's not necessarily that all the sides of both the triangles have to be the same, but it's the triangle has to have three pairs of corresponding sides. What this means is, first of all, let's just write the similarity statement here. So the second relationship that has to exist is the side-side-side relation, right? So in this case, say for example, I had triangle ABC over here, triangle A, B, and C, right? And I had another triangle D, E, and F, right? So I had both of these triangles. I knew that side AB is 3, side BC is 4, and side AC is 5. And I also know that side DE is 6, side DF is 8, and side EF is 10, right? What has to exist when you have a side-side-side relation is that three pairs of corresponding sides have to be proportional, sorry. And what this means is basically if I write this as a dual equation, which is basically AB, so side AB over side ED is equal to side BC over side DF is equal to side AC over side EF. Basically, when we plug in the different sides for what are the cases, A, B, D, F, B, C, whatever the case is, this equation has to hold true. So, and if this equation holds true with all the sides are proportional, that means that both of these triangles are similar. So let's look at it to make sure that this equation does work between both these similar triangles. So side AB is 3, side ED is 6, side BC is 4, side DF is 8, and side AC is 5, and side EF is 10, right? And when you simplify this, you get 1 over 2 is equal to 1 over 2 is equal to 1 over 2. And that is how we know both of these triangles are similar, because they have the same side proportional ratio, right? So now let's look at the third angle relationship, sorry, not the angle relationship, the triangle relationship, to find if two triangles are similar. So the third relation is the side angle side relation. So the SAS relation, right? In this relation, it's quite similar to the relationship above, the side 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 relationship, but it also incorporates something from the angle angle relationship. So in this case, say for example, I have triangle ABC again, triangle A, B, and C, and angle C was a right angle. And say I also had another triangle. I had triangle DEF, so DEF, and angle F was a right angle. And I only knew side BC, I knew it was 6, and I knew side AC was 6. And I knew that side EF was 6 also, and I also knew side DF was 12, right? So if two triangles like this were given, you could use the side angle side relationship to see if both of these triangles are similar. So for the side angle side relationship to work, the angle has to be contained between the two sides. What this basically means is if you have two sides, the angle has to be in the middle of two sides. So if you know x and y, the angle has to be in the middle for this relationship to work. So what you have to do to verify that two triangles share a side angle side relation is you have to again find the side proportions for both the sides, and if they are equal, you can move on to seeing if the angle contained is the same. So in this case, we have to write BC over EF is equal to AC over DF, right? And after we solve this, or moreover simplify it, we get 1 over 2 is equal to 1 over 2. So we do, and as a matter of fact, know that the side angle side relationship is present in both these triangles up till now. But we also have to look at if the contained angle is the same. And in this case, both contained angles are right angles. They're both 90 degrees. So we know that the side angle side relationship does in fact work. So that's about it on how to identify similar triangles. But now let's move on to why angle proportionalities and why identifying similar triangles is actually important. So say for example, you knew that both of these triangles, let's say triangle A, B, and C, was similar to triangle, let's say D, E, and F, right? You knew that both of these triangles are similar. And you knew that the similarity statement between both of these triangles were triangle ABC is similar to triangle DEF. And remember, the similarity statement is really important because it orders your corresponding angles together. So you know that angle A is equal to angle D, and angle B is equal to angle E, and angle C is equal to angle F. So the similarity statement is also really important. So say for example, you knew that angle B was 24 degrees, and you knew that angle A was let's say it was 53 degrees, right? How would you use the similarity statement to find out angle E and D? Well, it's quite simple. All you have to do is look at the similarity statement, and because you know B corresponds to E, you just have to match the angles. So now you know that angle E is equal to 24 degrees, and angle D, also due to the similarity statement, is equal to 53 degrees. And using the 180 rule, you can also find angle C and angle F. So that's one of the instances where similar triangles are really helpful. So another way similar triangles are helpful is by using the side proportion equation. Say for example, you have two triangles. In this case, again, we'll use A, B, and C, and we'll use D, E, and F, right? And again, you know that both of these triangles are similar, and the similarity statement is triangle ABC is similar to triangle DEF, right? You know the similarity statement. Now, say for example, apart from actually the angles itself, you had some of the sides of both these triangles. Say you had side AB, say you knew it was 6, and you also knew side AC, right? Or sorry, no, you knew side BC and you knew it was 8, right? But you didn't know side AC, right? You didn't know it, so let's put a variable x over there. But in this case, you also knew some sides of the second triangle. You knew that side DE was 3 and side DEF, in this case, EF is 2, right? But you didn't know what side EF was. Well, believe it or not, you could actually use these two similar triangles to find out the different sides of A and C and E and F without actually measuring it. Remember when we set up the side proportion ratio when identifying similar triangles? Well, you could use the same thing to solve for X and Y. So you know that A and B is proportional to D and E. So you can write that AB over DE is equal to, again, let's say AC over DF and BC over EF, right? Now all you have to do is you have to plug in as many sides as you know and how many ever variables you identified, and you can eventually solve for X and Y. So AB is 6, DE is 3, AC is X, we don't know that yet, DF is 2, BC is A, and EF is Y. All you need is one complete ratio, which in this case is 6 over 3, to solve for X and Y. All you have to do is line it up. So in this case, 2 is equal to X over 2. And so now we know that 4 is equal to X by simply solving this equation over here. And now you have to line up both of these equations to get 2 is equal to 8 over Y, or Y is equal to simply 8 over 2, or Y is equal to 4. So now you know that side X is equal to 4 and Y is also equal to 4. So again, that's how similar triangles are really useful. When you're actually given a word problem, it's important to find similarity, format the similarity equation, and then solve for what it's asking. So that's the end of the video, guys. I hope you learned something new. If you have any comments or concerns, please feel free to leave it down in the comment section below, and I'll look to get back to you as soon as possible. And thanks for watching, guys.